As you know, UTP cable is an essential component of a local area network. In this lesson, we will learn about its key characteristics that we need to know as a network engineer. In this video, we will talk about the following topics. First of all, we will start off with the UTP cable categories. From there, we will go into the UTP cable components. Then we answer the very important question, why twisted? After that, we will look into how to transmit data in twisted pairs. And finally, we will sum up our video with the keynotes. Let's start with the UTP cable categories because it gives us an overview of the UTP cable characteristics. Even though being divided into multiple categories, all UTP cable categories have the same maximum length of 100 meters or 300 feet. Now, let's go into the first category, Cat5 or Cat5e. Cat5 or Cat5e has 4 pairs of wires. It can transfer data up to 100 megabits per second. However, it is susceptible to noise. The next category is Cat6. Cat6 can transfer data up to 1 gigabit per second. As you can see, Cat6 has an additional core in addition to the 4 pairs of wires. The next category is Cat6a. Cat6a looks the same as Cat6, but it can transfer data up to 10 gigabit per second. The final category is Cat7. Cat7 can transfer data up to 10 gigabit per second. In Cat7, each pair of wire is wrapped. Let's look at this picture. This is the picture of the CCNA lab that I bought 5 years ago. However, today we don't talk about the CCNA lab, but we talk about the UTP cable components. The very first component of the UTP cable is the cable itself. And then, as you can see, each end of the cable is installed with an RJ45 connectors. Now, let's answer an important question. Why UTP cable is so popular in a local area network? As you can see, each network device nowadays usually comes with a built-in RJ45 Ethernet port where we can use UTP cable to plug in to connect those devices. That's make UTP cable is so popular, or it's become an essential part of the local area network. To understand UTP cable, let's look inside a UTP cable. As you can see in the picture, there are 4 pairs of wires inside a UTP cable: green, orange, brown, and blue. In a pair, there's one wire with solid color and the other wire with striped color. For example, the green pair has a solid green wire and a striped green wire. One thing that you can easily notice is that wires in each pair are twisted together. That is the reason why they call it twisted pair. But why twisted? To answer the question why twisted, let's first look at this picture where it shows the 2 wires, red and blue, running in parallel. Now, when electrical current passes over any wire, it creates electromagnetic interference EMI, showing with the yellow arrows over here. The EMI in turn creates induced currents, shown as the black arrows over here. You can see that the induced currents interfere with the electrical signals in nearby wires, including the wires in the same cable. And they call the interference between the wire pairs in the same cable crosstalk. you can figure out that crosstalk makes it difficult for the receiver to translate the electrical signal into data. Let's take a look at this picture where it shows the two wires, red and blue, are now twisted together. When electrical current passes over any wire, it creates EMI. However, the EMI now creates opposing induced currents in alternating twists, which cancel out each other. For example, this magnetic field creates this induced current and also this induced current, and this magnetic field creates this induced current and this induced current. As you can see, these two induced currents cancel each other out. Therefore, twisting the wire pairs together helps prevent crosstalk. Let's now move on to RJ45 connector. As you know, RJ stands for register jack. RJ45 connector has 8 pins into which 8 wires of the UTP cable can be inserted. How the wires in UTP cable terminated creates different types of UTP cable, such as straight-through cable or crossover cable, which allows us to connect appropriate devices together. Two wiring schemes T568A and T568B are used to terminate the twisted pair cable onto the connector interface. The RJ45 connector can be plugged into RJ45 Ethernet port. Let's analyze how to transmit data using twisted pair. As you can see, this diagram shows us the two network interface costs of device A and device B. To make it simple, we only show the network interface cost with two pins, pin 1 and pin 2. To create a circuit, Ethernet ports connect two wires in a pair to create a complete loop to allow electricity to flow between the sender and the receiver device. Now, to send the data, the two devices follow an encoding scheme with which the transmitting device changes the electrical signal over time, while the receiving device using the same rules to interpret those changes as either 0 and 1. That's how the data is transferred between the two devices using the twisted pair. Let's sum up our video with the keynotes. UTP cable in all categories has the same maximum length of 100 meters or 300 feet. Cat5 or Cat5e with speeds up to 100 megabit per second, while Cat6 with speeds up to 1 gigabit per second. Both Cat6a and Cat7 with speeds up to 10 gigabit per second. There are 4 pairs of wires in a UTP cable: orange, green, blue, and brown. These pairs are twisted together to prevent crosstalk. Each end of a UTP cable is usually installed with an RJ45 connector that has 8 pins into which 8 wires of a UTP cable can be inserted. RJ45 connector is used to plug into RJ45 Ethernet port. Ethernet ports create a circuit for each pair of a UTP cable for electricity to flow between two network devices, from which can be decoded into data as 1 or 0.